Good morning, student. Welcome to all. Today we are going to start a new chapter of physics that is known as laws of motion. We already discussed what is kinematics. In kinematics, we only deals with the motion of an object without knowing its cause. Clear? And mechanics means it is a three part. First one rest, second one we discuss or static, dynamic, and we will discuss here that is dynamic. So we already discussed first one that is static, and second one kinematic, and third one that is dynamics. Clear? So in static we already discussed body at rest condition or equilibrium condition, net force apply on the body at that time is 0. Then in kinematics we only deals with the motion of an object without knowing its cause. Now we will discuss the important chapter or important concept here, dynamics. Dynamics means we have to find here the cause of motion. We have to add extra parameter of motion. Clear? And that extra parameter is here force. In dynamics we deals with cause plus effect. So what is effect? Suppose I am taking here straight line motion. Suppose there is a body which is moving with initial velocity u. After some time it changes its velocity to v. Clear? So velocity change means there develop acceleration, and if there is develop acceleration, then we can say that if a body which changes its velocity due to an external agent or due to an external interaction with our surrounding and body, that external agent is known as force, because it changes its motion initial velocity u to final velocity v, means this is known as effect, and this effect happened due to one important cause, and that cause is known as force. Why body changes its velocity initially u to v due to the cause, and that cause is known as force. Clear? So force which changes the state of the body. State means rest, motion and direction. Clear? So we have to add another parameter here that is known as force. So force means it is an external agent or external interaction. It is an external agent to push or pull, which first point which produce or try to produce the motion. Which produce or try to produce motion in the body. Clear? Suppose body in rest position, if we apply force this direction, then it may produce the motion or it try to produce the motion of a body, and that effect is known as, and that cause is known as force. So it is the agent which push or pull. And second thing, which stop or try to stop. Stops or try to stop the motion of a body. And next point, which change the which change or try to change the direction of a body. And next one point, which produce the change in shape of a body is called force. So these are the important property of a force. Clear? So force is a vector quantity, and we already know the vector quantity which possess two important things. So first one is possess magnitude, and second one it possess direction. Clear? And here in the condition of force, there is third characteristic of force, and that the characteristic is known as point of application. Point of application of force. So this point of application clearly we discuss in rotational motion chapter. So just I am telling you what is point of application. You already know magnitude, direction, and third one point of application. Point of application means suppose there is a body on the surface. If we apply here, or you can take another one example here. Suppose there is a rod like this, and this point is fixed or hinge point about which this rod can rotate like this. So if we apply suppose here 5 Newton force, then it will turn like this or it will rotate like this. Same 5 Newton force if we apply here, then again it will rotate like this, but here effect is maximum, but here effect is minimum. So depends on point of application. If we apply force this point or if we apply force this point, then it depends on point of application. This is important point. Or again if we take another body is here on the surface of earth or on the surface. Suppose I am applying here 5 Newton force, this point 5 Newton force, then it will move or it will displace this direction along the direction of force. Or if we apply again this 5 Newton force at end point of this body here 5 Newton force, then it may rotate like this. It may rotate like this, means it may, if we apply force here, then it may rotate like this. So depends on point of application. Clear? So the important properties of force is first magnitude, direction, and third one point of application. Clear? Okay. Now we'll discuss different type of forces. Actually in nature there is 4 type of forces. First one gravitational force, second one electromagnetic force, and third one weak nuclear force, and fourth condition one, that is a strong nuclear force. Clear? So now we will discuss here according to their nature of the force. We will discuss the force which divided by 2 parts, and first one is known as contact force. Contact force, and second one, that is non-contact force. So what is contact force? Contact force means it is actual contact between source and object. Actual contact between source and object is called contact force. Suppose there is a spring like this, and if you want to compress this body and this spring which attached to a block, if you compress this direction, then it will move this direction or displace this direction. Clear? If you compress this direction, then it will displace this direction, so that it experience a force. That force is known as contact force, and we will discuss here. Inside the spring develop a oppositional force in this direction, and that oppositional force is known as spring force. Spring force. This is known as contact force. Another one example we can take here. Suppose there is a body like this, and the body which connect with a string, and if we apply force this direction F, then inside the string there develop two interatomic force or intermolecular force. That intermolecular force is known as tension. Clear? Tension is one type of force we will discuss while we are studying about free body diagram. We will clearly discuss about what is tension. Tension force is one of the most important example of contact force. So these are the examples, some example of contact force. We can say contact force is basically divided by first one, that is normal reaction, normal reaction, and second one, that is tension, and third one, spring force, and fourth one you can say that is friction. So what is normal reaction? Actually normal reaction means suppose there is a body which is staying on the surface of earth, or you can say the body which rests on a table, and suppose the mass of the body m, and due to gravitational force it experience a force in downward direction, and that force we already know, that is mg. Clear? This is known as gravitational force. So normal reaction means if there is a contact surface, there is normal reaction. So normal reaction develop always in contact surface between two bodies. Suppose this is first body and second body, and there is a contact. This contact surface, that develop another type of contact force. That contact force is known as normal reaction. Clear? And normal reaction always try to push the body, and normal reaction always perpendicular to that contact surface. Suppose this is contact surface, and normal reaction develop between two body. This is table, and here book. So normal reaction develop here, and normal reaction always try to push the body. Means here normal reaction develop in this direction, so it push the body upward direction or on the book, and that normal reaction always perpendicular to this contact surface. Second thing we will discuss Newton's third law of motion. Force always in pair form. Clear? Isolated force never exists in nature. Always force always in pair form. So if normal reaction this direction and this normal reaction try to push the book, then at the same time there is another normal reaction on the table, and this is also normal reaction, and this is the normal reaction. Their magnitude are equal, but they are opposite direction, and this two force develop between contact surface of book and table, and this normal reaction always perpendicular to this contact surface, and its nature electrical due to friction. Clear? We will discuss chapter in friction. Friction is basically electrical in nature. So this is known as normal reaction. We will discuss clearly while we are studying free body diagram. Next come to tension. This is tension, intermolecular attraction, and this is contact force. And next one spring force. Here this is known as spring force, which opposite direction of the external force. If we apply external force, then spring force always oppose the motion, or spring force always oppose the change in its configuration. Clear? And next one friction. So what is the meaning of friction? Friction develop in solid case, or friction develop between two contact surface. Clear? It depends on frame of reference. So suppose there is two body, this is first body and second body B, first body A. if first body and second body is at rest position, suppose first body moving with some velocity v and frictional force always develop between contact surface two body 1 and body 2, it is known as tangential force. Clear? Perpendicular force normal action, but tangential force is known as friction, and it always try to decrease the velocity of the body, and it always opposite direction of motion of the body. Clear? So if body A moving this direction, then a frictional force develop between their contact surface, and that frictional force always opposite direction of motion of the body. Clear? This body moving this direction, so frictional force, this frictional force act on body A. Clear? Means this body A here, this is the direction of velocity, and frictional force develop here. That force is known as frictional force. Clear? So this frictional force is another one example of contact force. These are the example of contact force. Next come to non-contact force. Non-contact force means there is no actual contact. No actual contact between source and object. That kind of force is known as non-contact force. And example of this non-contact force, gravitational force, and second one, that is electromagnetic force. Clear? So what is gravitational force? Gravitational force means, suppose there is a body mass m1 and another body here mass m2, and separated by a distance from their center r, then according to Newton's law of gravitation, the force and the nature of this gravitational force always attractive, or you can say the magnitude of attractive force is directly proportional to product of their masses m1 m2 by square of distance between them. This is known as gravitational force, and that gravitational force is non-contact force, because there is not actual contact between m1 and m2, but they experience a force, and that attractive force is known as here gravitational force. Clear? So if we take another one example here, the earth revolves around the sun. Suppose this point, this is sun, and this is the path of the earth, and it revolves around the earth, and at the time is possess some mass, earth also possess some, suppose mass m1 and m2, and there is separation between them, suppose r. So here there is a attractive force this direction, and this attractive force is known as gravitational force, and here though there is no actual contact between earth and sun. Clear? So this is known as non-contact force. Clear? Okay. So you can take different type of example. The electron revolve around nucleus, this is also known as non-contact force. Clear? Okay. Next, another type of force is here, electromagnetic force. Actually it is also two part. First one electrostatic force, and second one magnetic force. So what is electric force and magnetic force? Electric force and magnetic force. Electric force, its nature is two type, attractive and repulsive nature. We will discuss details in second year what is electric force and magnetic force. Just I am giving some example or basic idea about what is electric force. Suppose there is a charge particle plus q and another charge particle here minus q, and there is not actual contact between these two forces. Clear? And separation between them, suppose r, at that time they will experience a attractive force due to their opposite nature, because here positive charge and negative charge, and that force, magnitude of this force directly proportional to magnitude of their charges and product of their charges q1 q2 divided r square. Clear? This is known as non-contact force is here. Clear? And similarly magnetic force means, suppose there is a magnet and North Pole and South Pole, and there is one iron bar, or you can say there is one iron piece, and it attract towards this magnet. Clear? Actually there is not actual contact between this object and source, but the iron which move towards this magnet, or magnet which move towards this iron piece. Why? Due to attractive force, or due to force between them. So that type of force is known as non-contact force. Clear? So there is basically two type of nature of force: contact force and second one non-contact force. You have to remember this type of force. Clear? And there are another different type of forces. You can say time dependent force. So what is time dependent force? Time dependent and time independent and velocity dependent, etc. These are the example of force. So here time dependent means, suppose I am writing here F equal to 2t, means if time increase then force also increase. Clear? You can say this is known as time dependent force. Similarly time independent force. Time independent force means you can say constant force also time independent force. Suppose F equal to, I am writing here 2 Newton. This is time independent force, always constant in nature. Clear? And another type of force is here velocity dependent force. So what is velocity dependent force? We will discuss in second year chapter. That is F equal to Q V cross B. Clear? This force is known as magnetic force is here. So if velocity of a body increase, that time the force also increase. So these are the example of some basic nature of forces. Clear? So now let's start laws of motion. And laws of motion is important. We will discuss here Newtonian mechanics, or simply we can say classical mechanics. So here first we will start laws of motion. Newton's laws of motion. First we will start Newton's first law. Newton's first law of motion. So what is Newton's first law, or what is Newton's laws of motion? So now we will start first Newton's first law of motion. Newton's first law means everybody unable to change their state of rest or state of motion, everybody unable to change their state of rest or state of uniform motion in a straight line unless an external force acted on it. This is the statement of Newton's first law of motion. So according to this definition, or according to this statement, everybody unable to change their state of rest. Suppose a body which is lying on the surface and initially is at rest, it unable to change their state of rest, means it unable to change their state by itself. Clear? If body initially velocity 0, then after some time also its velocity 0, after 1 hour its velocity again 0, means it always state of rest. It cannot change by itself its state of rest. So that property is known as inertia property. Inertia property of a body. Clear? And second thing, if a body which moving with constant velocity or uniform motion in a straight line direction, suppose this is frictionless surface and a body which moving 5 meter per second, suppose time t equal to 0. I observe that time t equal to 0, its speed 5 meter per second. After 10 seconds, this body also moving same 5 meter per second and again same direction. After 10 seconds, again body moving with same velocity 5 meter per second, again same straight line direction. So here the body which remain at is initially at rest position remained at rest. The body which moving with uniform velocity in a straight line direction, it will move this direction, it will continue to its motion or it will continue to its state of rest or state of motion unless an external force applied on it. If we apply any external force at rest condition, suppose I am applying force here, then it changes its position A to position B and it may change its velocity V. Clear? So there is an external force required to change the state. If we don't apply any external force, then the body remain its initial state, means rest position or a body moving with constant velocity like same direction. Clear? So there is an external agent. That external agent is known as force is here. This is known as Newton's first law of motion, and Newton's first law of motion describe the inertia property of a body. So what is the meaning of inertia? Now let's start. What is inertia property of a body? Inertia. Inertia means jadatva. So the definition of inertia is that it is the inherent property of a body. It is the inherent property of a body which unable to change by itself is called inertia. So inherent property of a body which unable to change itself, जे निजे निजे निजर स्टेट चेंज करि पारेनी, मीन्स सपोज ए बॉडी इनिशियली रेस्ट कंडीशन, इट ऑलवेज इन द स्टेट ऑफ रेस्ट. जे रेस्ट कंडीशन रे अछि सब से रेस्ट कंडीशन रे थिबो, और व्हेन ए बॉडी विथ मूविंग सम कांस्टेंट वेलोसिटी only one direction, then this body try to continue this velocity along this direction, means जो body motion condition रे अछि सेम सेम मोशन कंडीशन रे थिबो, से ता डायरेक्शन आ वेलोसिटी को केबे भी चेंज करि पारो, निजे निजे केबे चेंज करि परिबा नाही. अगेन ए बॉडी मूविंग सपोज टुवर्ड्स ईस्ट डायरेक्शन विथ सम वेलोसिटी, देन बॉडी कंटिन्यू टू दिस पाथ और कंटिन्यू टू दिस स्टेट. जे ईस्ट डायरेक्शन रे इनिशियली मोशन रे अछि से ईस्ट डायरेक्शन रु केबे वेस्ट को जाई परिबो नाही, अनलेस एन एक्सटर्नल फोर्स अप्लाइड ऑन इट. जे पर्यंत आम एक्सटर्नल फोर्स बाह्य बल ता ऊपर न देबा से जाए बॉडी से सेम डायरेक्शन रे मोशन रे थिबो. सो इनर्शिया मीन्स इट इज इनहेरेंट प्रॉपर्टी व्हिच अनेबल टू चेंज बाय इटसेल्फ इट्स स्टेट ऑफ रेस्ट और स्टेट ऑफ मोशन और स्टेट ऑफ डायरेक्शन. क्लियर? सो inertia is basically three type of inertia is here. So first one, inertia of rest, and second one, inertia of motion, and third one, inertia of direction. So inertia of rest means the inability of a body to change by itself its state of rest is called or is known as inertia of rest. Inertia of rest means suppose a body initially at rest at point A, after some time this body also at point A, after some time also body at point A, means if we don't apply any external force on that body, then it will try to remain in the state of rest position, means it always try to remain its initial state. That is known as inertia of rest. Or you can take another one example. Suppose you are inside a bus and the bus is rest condition. Clear? So when bus suddenly start moving or bus suddenly accelerate, means acceleration not equal to 0. When bus suddenly start moving, at that time you fall backward direction. Why? So here initially your body is rest position with the bus, and if you divide your body, suppose I am drawing this diagram here, and this is bus. Inside the bus, there is a friction between the floor of the bus and your feet. So this is rest position, and I am dividing this your body in two parts. This is upper part and this is lower part of the body. Initially body at rest position means initial velocity of the body rest, means your velocity also rest. So when bus suddenly start moving or suddenly accelerate, at that time if bus accelerate this direction, then your body will be like this. Why? Because this part or your feet which attach with the bus, and bus which suddenly start moving this direction, then lower part which moving this direction. Clear? So lower part displace here this point to this point, but your body always try to maintain its inertia, always try to maintain its state of rest. Initially rest position रे थिला, जदि लोअर पार्ट तुम मोशन कंडीशन को हो जाउजी, बट अपर पार्ट कौन चाहूजी, अपर पार्ट ऑफ द बॉडी ट्राई टू रिमेन इट्स स्टेट ऑफ रेस्ट, ये रेस्ट पोजिशन होया पाई चाहूजी. जदि ये लोअर पार्ट आकु पड़ गला तले अपर पार्ट से पोजिशन रे मेंटेन करिया को ट्राई करे, सो दैट यू फॉल बैकवर्ड डायरेक्शन. दिस इज नोन एज inertia of rest position. Clear? So another one example you can say, while you are sitting on a horse, when horse starts suddenly moving forward direction, then it will fall backward direction due to this property or inertia of rest position. These are the example of inertia of rest. Clear? And next come to inertia of motion. So the inability of a body, inability property of a body due to which body to change by itself its state of rest. So here you have to write only its state of motion. State of motion is called inertia of motion. So if you take example of inertia of motion, suppose there is a passenger inside the moving bus and bus moving with velocity v, one passenger inside this bus. Suppose passenger here, this passenger also moving with velocity v. Why? Because passenger sitting in a moving frame. suppose this bus suddenly stop moving. Suddenly stop moving means its velocity instantly suppose 0. Suddenly stop moving, and at that time you fall forward direction. Why? Because your total body, whole body, which moving with same velocity v as velocity of the bus, when bus suddenly apply brake, at that time its velocity is 0. If velocity is 0, then your body is moving this direction. So this part means lower part of the body is now rest condition, but upper part of the body try to maintain its initial condition. So what is the initial condition of this man? Its initial condition is motion, because upper part of the body not attach any contact, or there is not contact between upper part and of the body, so that it will fall forward direction or along the direction of initial motion. Clear? So initially bus ro velocity or bus ro motion जो डायरेक्शन रे थिबा, बॉडी से सेम डायरेक्शन को फॉलो करे. व्हाई? ड्यू टू इनर्शिया ऑफ मोशन, सो दैट इट विल फॉल दिस डायरेक्शन मीन्स फॉरवर्ड डायरेक्शन और along द डायरेक्शन ऑफ वेलोसिटी. क्लियर? इमेजिन करो तुम ट्रेन रे अछ, सपोज ट्रेन मूविंग दिस डायरेक्शन and one passenger try to jump on the ground from train. जने ट्रेन रु ग्राउंड को जंप करिया पय ट्राई करछ, ताले से को डायरेक्शन रे जंप कले और को डायरेक्शन रे मोशन कंडीशन को आसिले ता बॉडीटा से डायरेक्शन चलथियो, मीन से पड़ी बन टोटली ऊपर भी किछि एक्सीडेंट हेबार चांस न थाए. सो एट दैट टाइम इफ यू मूव एंड व्हाइल यू आर जंपिंग from the train to ground, so you have to move along the direction of this train. जब तुम ट्रेन रु सडनली ओल्हेला पर से सेम डायरेक्शन रे मोशन रे जीवो, ताले तुमको ठीक इनर्शिया मेंटेन हो जीवो. व्हाई? बिकॉज योर बॉडी इनिशियली मूविंग दिस डायरेक्शन, सो यू आर मूविंग विथ ए फ्रेम व्हिच मूविंग विथ वेलोसिटी v. नाउ यू आर जंपिंग फ्रॉम मूविंग फ्रेम टू रेस्ट फ्रेम, एंड इफ यू मूविंग दिस डायरेक्शन on the rest frame, so that your body also moving along the direction of initial velocity, so that you can maintain your inertia of motion property. Clear? So these are the example of inertia of motion. And last one example, inertia of direction means its state of rest, state of direction. So the inability of a body to change by itself its state of direction is called inertia of direction. Clear? So inertia of direction means, if you take example here, suppose you are moving with a bus and this bus with moving some velocity v, and you are sitting here inside the door. Suppose inside the door you are sitting like this, and this bus suddenly take a sharp turn like this. If bus suddenly changes direction from initial direction, then at that time your body also follow the same direction initially, and when it takes sharp turn, then your body try to maintain its initial state of direction. So its initial state of direction means it was your initial state of direction. So when it takes sharp turn, then your body try to move this direction, so that you will face a force or you will hit the door like this. Clear? So तुम door रे एबे hit ही जीवो, और it will experience a force towards the forward direction if we take a turn towards backward direction. Clear? So these are the example of inertia of डायरेक्शन. सो इनर्शिया मीन्स इट इज इनहेरेंट प्रॉपर्टी, जे निजे निजे केबे भी चेंज करि परिबो नाही. क्लियर? सपोज बस स्ट्रेट लाइन मोशन रे जाउची, सडनली लेफ्ट टर्न नेला, बट तुम बॉडी को पोजिशन रे अछि, स्ट्रेट लाइन डायरेक्शन रे सो तो से लेफ्ट टर्न नब तुम स्ट्रेट लाइन मोशन को मेंटेन करिवो सो दैट इट विल फक इफ बॉडी टेक ए शार्प टर्न टुवर्ड्स लेफ्ट then it will experience a force towards right direction. This is known as the inertia property of a body. Means it is unable to change its state of rest, state of motion, state of direction unless an external force acting or unless an external force applied on it. Clear? So these are the basic or fundamental thing about laws of motion. So you have to just remember this example: what is inertia of rest, what is inertia of motion, what is inertia of direction, what is inertia, and what is Newton's first law of motion. Clear? Thank you all.